Good morning, class. This is Mr. Roberts standing here in room 309 at Shasta High School and watching the moon set. I have two sequences that are up on the screen here, one on the left and one on the right. The first sequence on the left is 6, 12, 18, 24. That is an arithmetic sequence because what I'm doing each time is I'm adding 6. 6 plus 6 is 12. 12 plus 6 is 18. 18 plus 6 is 24. And the rule for that, if I think about it, the zeroth term is 0. If I brought this back to the 0th term, I would get the number 0. So the explicit rule for this, I would write the following way. I'd say t of n is equal to 6 times n. I could say plus 0 if I want to just show that the 0th term is there. So that's the explicit rule for this sequence. Another way to write it, that's the explicit rule, is the recursive rule. And if I want to write the recursive rule, it takes two pieces of information. One of the things I have to tell it is what the first term is. So I'll just say, if I want to write the recursive rule, I would say that t of n, or t of 1 rather, is the number 6. So that's how I've done this in class. The first term is 6. And then I could say, hey, I could say this. I could say that in order to get to the next term in the sequence, so I could say t of n plus 1. So what I'm saying is the next term in this sequence is going to equal whatever the current term is. So I'll say t of n and then plus 6 more. So take a look at it. It's a little different, but it says in order to get to the next one, right? So the one that I'm at is t of n. So anywhere in this sequence I could say this is t of n where n is 3. And then if I want to get to the fourth term, right? If I'm at the third term, if I'm where n is 3, t of 3 is 18. If I want to get to the fourth term, if I want to get to the t of 3 plus 1, the fourth term, I simply add 6. So that's a nice notation, and that's how that works. So this is the explicit rule, and this is the recursive rule. There's a couple variations I could do on the recursive rule. I could also say this. I could say, hey, same thing. I could say the first term, right, is equal to 6. But I could also say this. I could say in order to get to any term, I could say, like, for example, if I wanted to get to the, if I want to get to the t of n term, if I want to get to any term, what I do is I take the term before that. So I could say take the t of n minus 1, right, and add 6 to that. So if you look at it, they still have the same relationship right here. That it's like this is the next one and this is the one that precedes it, right? The one in the future, the one that I'm at. This is to get to the one that I want to be at, go to the one that was right behind me. But it's still the exact same thing. So if I want to know what the fourth term is, right? If I want to know what the fourth term is, it says, oh, okay, to get the t of n plus 1, if you want this to be the number 4, that says you need to know the third term. See that? If you want to know the fourth term, you need to know what the third term is. Okay, if I want the fourth term, I need to know the third term. And to get the third term, to get the fourth term, I just take this third term and add 6. This says the same thing, and in a way, it seems like it says it in a little bit clearer fashion. It says to get the fourth term, simply take the third term and add 6 more to it. One of the things I want to point out is when you see this notation, t of n, what they're saying is the output of this sequence when you know what the value into it is. So when I see t of n minus 1, I'm talking about a specific value in the sequence as opposed to a number in the sequence, right? This is the first, second, third, fourth. All right, so let's do the similar thing. So again, just to review, this first one is the explicit sequence. It's got my slope of 6. It's increasing by 6. It's a linear relationship, and the 0th term is 0. This one starts at 1 and it increases by 6. So this next one is a geometric sequence, and similar thing, right? If I want to know what the if I'm going forward, what am I doing each time? I'm multiplying by the number 6. No, by the number 2. I keep multiplying by 2's, and if I back up to the 0th term, I get the number 3. So let's write what this is as an explicit rule. The explicit rule is that if you want to get any term in the sequence, what you do is you take the number 3, which is my 0th term, and you're going to multiply that by 2 raised to the nth power. So if you look at what's happening here, it says, hey, you can get to the any term by just taking and putting in the term number that you want. So if I put in 1, if I want to know the first term, this becomes 3 times 2, right? If n is 1. If I want to get the second term, this becomes 3 times 2 to the second power, because I want the second term. 3 times 4 is 12. 2 to the third power, 1, 2, 3, this is the third term. 2 to the third power is 8, and 3 times 8 is 24. So that works quite nicely. That's how you get any term using the explicit rule. The recursive rule looks like this. Again, you have to tell it what the first term is. So I'll say that t of 1, the first term is the number 8. Yes. No, the first term is 6. I'm sorry, it's not 8. The first term is 6, and to get to a term in the sequence, well, I'm going to do it both ways like I did over here. To get to the next term in the sequence, what we do is we take the term that we're at, and we're going to multiply that by the number 2. And I guess I'm going to put a 2 here. 2 times that. Ooh. Maybe I'd put it like this, just 2 times to the n. Looks a little ambiguous to me. Maybe I would put a dot. I'm not using my pen right now, so a dot's a little problematic. So I could do this. I could say times 10. There we go. I could do 2. This is clearly not an x. This is multiplication. 2 times t to the n. So in order to get the next term in the sequence, just take the term that you're at and double it. And I can write that in a similar way that I did below over here. In fact, let's do that. The other way that we wrote that here was, I could say, again, the first term is 6. And to get to any term in the sequence, what you got to do is you got to take the term right before it. So I'm going to say take the t of n minus 1, the term before the term that you want, and you take that and multiply it by 2, and I'll do this the same way, 2 and then t-i-m-e-s. So 2 times the term that preceded it. All right, so and there was another bit of information in our textbook regarding using subscripts. I just want you to be aware of that today, especially because when you look at assignments in Delta Math, in fact, let me show you one of the problems here. In Delta Math, they're going to play this game where they're going to want, if you're asked for the recursive formula, they're going to want to know what the first term is. So this is using a subscript. So say, this is exactly the same as saying, what's the t of 1? So the subscript says, which term in the sequence do you want? So this would say, okay, I want the first term, which is in this sequence is 8. This sequence is arithmetic because it looks like I'm just subtracting 6 each time. 8 minus 6 is 2, 2 minus 6 is negative 4. So in order to get to the next term, I simply take the previous term, and that's easy because they've got this set up right here, and I just subtract the number 6 from it. So I kind of like how this looks, right? In order to get to a term, you take the previous term and subtract 6, and you'll get it. Let me check that real quick. Okay. And it says I was fortunately correct, so good. So that's one way that you can write this, right? It is an arithmetic sequence, and we're decreasing by 6. So when you see that notation, right, our book talks about it, and it is going to show up in Delta Math at some point too. All right, have a great day. Please complete the entire review assignment in Delta Math. And we'll be doing a different assignment in class. So this assignment is intended for your day that's away. So if you're away on Monday, do it now. If you're away on Tuesday, you can save it for Tuesday. This is Mr. Roberts. Talk to you later.